Hi everyone. Okay, I have an equation solving potpourri, but I think quadratic techniques, when I looked at the actual examples I used, are what we have. So we're just going to expand. We're going to delve into it a little further. Now, you notice the square and the first power on the parentheses here, and then the constant. That looks like a good topic for quadratic techniques. So I'm going to, on this problem, I'm going to let u equal x over x plus 1. And then I'll write 6u squared plus 5u minus 6 equals 0. Well, let's see. What multiplies to negative 36 and adds to 5? I think 9 and negative 4. 9 times negative 4 and 9 plus negative 4. So 6u squared plus 9u minus 4u minus 6 equals 0. Let's group these. Let's see, 3u times 2u plus 3 minus, looks like negative 2 is the greatest common factor there. And then you got 2u plus 3 there equals 0. My GCF, or the common factor there, is 2u plus 3. And then I got 3u minus 2 here equals 0. 2u plus 3 equals 0, or 3u minus 2 equals 0. And when I subtract 3 and then divide by 2, I think you'll see u is 2/3 here. And no, it's negative 3/2. That's probably why I should write out the steps. And then when I add 2 and then divide by 3, I'll get u as 2/3 here. Alrighty. Now remember, now it's time to put what u is equal to back in. So x over x plus 1 equals negative 3/2. I'm going to use the means extremes property here. Cross multiply. 2 times x equals negative 3 times x plus 1. And 2x equals negative 3x minus 3. And I'm going to subtract 2x. No. What am I doing? Let's add 3x to both sides. And I'm looking at here, 5x equals negative 3. So x is negative 3/5. Got one of my solutions there. And let's see. Oh, u is 2/3. So x over x plus 1 equals 2/3. That looks pretty easy. It looks to me like x is going to be 2. And 2 plus 1. But let's just practice. 3x here. 2 times x plus 1 here. And 3x equals 2x plus 2. When I subtract 2x from both sides, I do have x equaling 2. Alright. I think we probably ought to be checking. Now, negative 3/5, so negative 0.6. I'm going to use negative 0.6 here. So let's turn it on here. 6 times negative 0.6 divided by, and I got to group this, negative 0.6, actually, let's, negative 0.6 plus 1 is 0.4, so rather than getting all these parentheses involved, I'm just going to go ahead and do that. Negative 0.6 plus 1 is 0.4, and I'm going to square that right there, plus 5, and then again, negative 0.6 divided by 0.4, and then I'm going to subtract 6 and hope for 0, and that's what I got. Alright, so that negative 3/5 does work. Circle that as a solution. 2, does it work? Well, 2 over 2 plus 1 is 2/3. So let's go 6 times 2 divided by 3 squared plus 5 times 2 divided by 3 minus 6. I got 0 for that also. Alright, so we got our two solutions there. Alright, there's one problem down. Just hoping we're understanding that substitution thing we do so that we can look at a quadratic, solve the simpler quadratic, and then replace the u with what u is equal to and finish solving. Alright. Now, this one may not be quite as easy to recognize. 6x minus 7 radical x minus 3 equals 0. Now, we could actually solve the radical equation, and that might be interesting maybe just to try the alternative version in class. But I'm going to use the quadratic technique here because this is interesting. You know, you've got x squared, ax squared plus bx plus c for a general quadratic expression. This power is twice as big as this power. Well, this power is 1, this power is 1/2, so this power is twice as big as this power. So if we let u equal this, the square root of x, then u squared is the square root of x squared, and the square root of x squared is just the x. So I can go 6u squared here minus 7u minus 3 equals 0. Okay, let's remember, I got a bunch of stuff up there. Let's remember that u is equal to the square root of x. If I square the square root of x, that's the x. And there's u being the square root of x, and then the minus 3. So what multiplies to negative 18, 6 times negative 3, and adds to negative 7? Okay, I think we get a 9 and a 2, and we make the 9 negative. So we got 6u squared minus 9u plus 2u minus 3 equals 0. 3u. Let's do 3u, because there's u in both those. And then we get 2u minus 3 plus, there's no GCF there other than 1. And then 2u minus 3 times 3u plus 1 equals 0. 2u minus 3 equals 0, or 3u plus 1 equals 0. Add 3 divided by 2, I think we're looking at u equals 3/2. Subtract 1, divide by 3, or u equals negative 1/3. And now it's time to take the square root of x, equals 3/2. And to undo the square root, we square. So x is equal to 9/4. Or square root of x equals -1/3. And square both sides, x would be 1/9. Alright. Well, it's checking time. Okay. So let's try 6 times 9/4. 6 times 9 divided by 4 minus 7 times the square root of 9 divided by 4. Hit the arrow to stop the radical there. And then minus 3. That is 0, so 9/4 is a solution. Let's try 1/9. 6 times 1 divided by 9 minus 7 times the square root of 1 divided by 9, arrow, minus 3 is not 0. Okay. This is, I know the square root of 1/9 is 1/3, so this is -7 times 1/3 minus 3, and 6/9 is 2/3. So 2/3 minus 7/3 is -5. Yeah, it's just too negative for that to work. So this is an extraneous solution. Alrighty. Okay, last one for this video. We have pretty big numbers here. First thing I think I want to do is let's not do decimals. Let's multiply through by 10. You got one decimal place. Multiplying through by 10 will move that and make this 84. Oops, 84 x to the 2/3 minus 12 x to the 1/3 equals 240. I'm going to subtract 240 from both sides. And I've got 84 x to the 2/3 minus 12 x to the 1/3 minus 240 equals 0. Okay. 12 times 7 is 84. I am going to divide this whole thing by 12. 84 divided by 12 is 7. X to the 2/3 minus x to the 1/3 minus 20 equals 0. Okay, you see this is twice as big as this one, and this is a quadratic technique problem. Let's let u equal x to the 1/3 power. And it's always this middle term that we let u equal when we try to use quadratic techniques. I don't think I've said that before, but I'm saying it now. So this is 7u squared. 2 times 1/3. 2 times 1/3 gives 2/3. Minus u minus 20 equals 0. Well, what multiplies? Okay, this could be interesting here. I'm just checking. We did do that right. What multiplies to -140 and adds to -1? 14 times 10, 20 times 7. Okay, I'm not seeing anything there. And I don't know if I'm missing something. Let's do the Mr. Petrella technique here. Clear that. And let's take 140 divided by x. Let's look at the table. 2 times 70, 4 times 35 times 28, 8, 9, 10 times 14, 11, 12 doesn't work, 13, 14 times 10. Okay, I am not seeing anything that will work there. So, let's let A equal 7, B equal -1, and C equal -20. And U equals -B plus or minus the square root of B squared minus 4AC. All of that over 2A. Okay. All right. What is, this is 1 minus 4 times 7 times -20. So 561. 1 plus or minus the square root of 561 over 14. Okay, that's what U is. And what a mess here, huh? Because we could take the cube root of this when we're done. I'm just curious about 561. First of all, what's the square root of 561? Okay, nothing nice here. I'm going to just look at simplifying that. Taking 561 divided by x and looking at the table. 11 times 51. And 51 is 17 times 3. So this is not going to simplify any. At this point, with this kind of number, these kind of numbers here, I am going to estimate from here. Okay, so we're going to go with the 1 plus or minus. Usually we simplify. This time we are going to approximate 23.685 over 14. And that is 24.685 over 14, or 1 minus -22.685 over 14. And let's just do that to 3 decimal places. Let's divide, nope, I don't have the number in here. 24.685 divided by 14. I'm going to go 1.763. Now remember, this is U. And negative 22.685. Wait. 1 minus. Okay. Negative 22.685 divided by 14 is negative 1.620. Alright, so what's U equal? U equals x to the 1/3. Okay, I'm running out of room, but that's cube root. So I'm going to raise both sides to the third power. And I'll write it up here, and I'm not checking if it's all the same with you. 1.763 to the third power. 5.480. That's one solution I've got. And then negative 1.620 to the third power. Negative 4.252. All right, those are my two approximate answers for this equation. All right, you guys, we're going to have fun with these, huh? I'll see ya.